Good evening, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic piezoelectric and pyroelectric effect from the subject Advanced Sensor Technology. So first, what is this piezoelectricity? So when a crystal undergoes any mechanical stress, it will be generating an electrical signal, which is nothing but it is an electric voltage. The word piezo is nothing but it is derived from the Greek word piezo, which means that to squeeze or press. So this piezoelectricity can be reversible. So in piezoelectric effect, when we apply some mechanical stress to a crystalline structure, it will be generating the electricity. And this effect can also be reversible. So when an electrical field can induce a mechanical deformation, this we call it as an actuation. What are all the key piezoelectric materials? It can be a natural one or it can be a synthetic one. So under natural materials, we have quartz, rochelle salt and tourmaline. Under synthetic material, we have lead, zincornate, titanate. And the first thing is the direct piezoelectric effect will be giving a mechanical stress to the crystalline lattice, which causes a displacement of a charges, which generates the electric charge and proportional voltage signal. The formula for this is given by charge is equal to D star F, where D is a piezoelectric coefficient, F is a force. For example, an 1 millimeter thickness piezoelectric sensor can produce a voltage of about 100 millivolt for a 1 Newton force. And next is the inverse piezoelectric effect, which we call it as an actuation. An applied electrical field can deform the crystal, results in a strain or a displacement which is proportional to the applied voltage, which is given by strain is equal to D star E, where D is a piezoelectric coefficient and E is the electric field applied, which is proportional to the strain. An example, a 10 millimeter PSD stack actuator can achieve a displacement enabling the ultra-fine adjustments. And next is the applications. Under direct effect, what are all the applications for piezoelectric effect? It can be employed as it can be employed in the airbag deployment. As the sensor used for this purpose is an accelerometer. Pressure sensor comes under the category. Microphones, medical ultrasound and sonar. These are all the sensors that exhibits the piezoelectric effect. And next, what are all the advantages and limitations of piezoelectric effect? First thing is that it is of self-generating and it is highly sensitive and it produces a very fast response time, and the frequency range that is operated under this piezoelectric effect is wide and it is of very compact size. Limitation is that it is widely dependent on temperature and it is fragile, which means that we are using only the crystalline lattice which can easily break down. And next is it produces a high impedance output and material constraint. The materials have to be chosen by natural or synthetic one. And next is a puzzle. I love the dark but work with light. Switch on lamps when it is not bright. The sensor related to this is nothing but LDR, light dependent resistor. I feel the heat but never sweat. Your AC listens to me. You beat. The sensor employed in this is a thermistor. I spin and twist to guide your way. Pilots and gamers will with me play, which is nothing but gyroscope sensor. Though I have no eyes, I can measure the distance of what's nearby, which is nothing but ultrasonic sensor. And next is a pyroelectricity. In piezoelectricity, when a stress is applied to a crystalline structure, it will be generating the electric voltage. So whereas pyroelectricity is a thing which is here the electrical signal will be generated whenever there is a change in the temperature. So to generate a temporary voltage whenever the crystalline structure is subjected to the change in temperature. So in piezoelectricity there will be a generation of charge in response to mechanical stress. In pyroelectric sensor respond to the rate of the temperature change. What are all the key pyroelectric materials? It can be a lithium tantalate, triglycerin sulfate, lead zincornate titanate, polyvinyl fluoride and barium titanate based on the applications used. And final is a application of pyroelectric sensor. The most widespread application is a most a widespread application is the motion detection. Here is a passive infrared sensor is being used. It is for detecting the persons or animals. Mainly is used for surveillance. The human body will be producing a infrared radiation which can be easily detected by this passive infrared sensor. So the directed infrared radiation will be easily detected by this passive infrared sensors, and it will be sensing and it will be converting it to an electrical signal. So this type of sensor can be easily integrated into a security alarms, automatic lighting and smartphones. And it is one of the main advantages of this passive infrared sensor is a cost effectiveness. And next is advantages and limitations of this pyroelectric sensor. The main advantage is that it doesn't require any active power for detection, and it is highly sensitive, and it consumes very low power, and it is very robust and long, and it has a long lifespan, and it is very cost effective. Limitation is that it can change the detections. It responds to the temperature change, not the absolute temperature, and it can even indicates a false alarm, and we need an extra IR transparent window for this, which is a design complexity, and the electrical output is often very small, so we require any amplifier to boost the signal. Finally, assessment question. The electromagnetic induction is a piezoelectric effect. Which of the following is a common application of piezoelectric sensor? Which is nothing but it is a monitoring vibrations. What type of material is typically used in piezoelectric sensor? Which is nothing but the materials which exhibit piezoelectric effect. Which of the following is not a typical application of piezoelectric sensor? Which is a strain gauge for static load measurement that comes under the principle of resistive. So that's all about the piezoelectric effect and pyroelectric effect. We have studied the concept and we have also gone through the applications. Thank you.